for number 4 here, rather than have two things multiplying to see whether they're positive or negative, we have two expressions being divided. And you know that the rules for multiplication and division with negative numbers are the same for whether you have multiplication or division. So I can still identify that my critical values are going to be the values that set the numerator and denominator equal to 0, specifically -2 and +3. And what I'm going to have here when I draw my number line is 3 regions that I need to check. I will try 0 in the center, -3 on the far left, and 4 on the right. When I substitute -3 in, my numerator becomes -1, my denominator is -6, and I have negative divided by negative, which is positive, and that's supposed to be less than 0, so that will not work. Let's try 0. When I substitute it in, I get 2 over -3, which is negative, and we want this to be less than 0, so that works. Similarly, 4 substituted in gives me 6 over 1, which is positive, and so that is not part of our solution region. Now, because this is a less than problem, we are not going to include either endpoint, and we wouldn't be including the 3 anyways because 3 is not part of the domain. So our solution region will be from -2 to 3. I put number 5 in here as a twist here because it's not already factored. I'm going to need to get 0 on the right hand side and subtract these two terms that we see on the right over to the left. This gives me x to the third plus 4x squared, sorry, that should be a minus because I'm subtracting it to the left, minus 9x plus 36 greater than 0. I can now factor this by grouping, and out of the first two terms I can factor an x squared and have left over x minus 4, and factor a minus 9 out of the third and fourth term to have an x minus 4 greater than 0. Since I see x minus 4 showing up twice, I can factor it out up front. I'm left with x squared in the first half of the parentheses and minus 9 in the second half. So there we have it factored by grouping, but I can go a little bit further because x squared minus 9 is the difference of two squares. And so I've got x minus 4 times x minus 3 times x plus 3 is greater than 0. And now I've got 3 critical values, and I can draw a number line here. Critical values at -3, +3, and +4. Let's try -4 on the far left as a test value, 0 in the center. I guess I'd have to go with 3.5 between the 3 and the 4, and 5 on the far right. Let's start with -4. -4 minus 4 is -8, so I've got negative in that first region. -4 minus 3 is -7, so I have negative again. -4 plus 3 is negative, so I've got negative again. So negative times negative times negative is negative, and we want it to be greater than 0, so to that region. Let's try 0. 0 minus 4 is negative, 0 minus 3 is negative, but 0 plus 3 is positive. Negative times negative times positive is positive, which is greater than 0, and so 0 is going to be in one of our solution regions. 3.5. 3.5 minus 4 is negative. 3.5 minus 3 is positive. Let's change that to a positive. 3.5 plus 3 is 6.5, which is positive. Now, negative times positive is negative, and that is not part of our solution region. When you substitute 5 in, all 3 regions become positive, which means that 5 will be in our solution region, and our solution to this inequality will be the set from -3 to +3 united with the set from 4 to infinity. In this final problem, we do not have a 0 on the right hand side of the equation, and so what we need to do is subtract 5 on each side, and this will make this -5 less than or equal to 0. We then need to put them over a common denominator in order to add the fractions, and that means we need to multiply by x plus 6 over x plus 6. what we're going to have now is x minus 2 minus 5 times x plus 6 all over x plus 6 is less than or equal to 0. Now let's do some distribution up in the numerator. X minus 2 minus 5x minus 30 will all be over x plus 6, and that will be less than or equal to 0. And we can combine like terms in the numerator to get negative 4x minus 32 all over that x plus 6 is less than or equal to 0. Now we notice that the numerator can factor, and we will have negative 4 times x plus 8 all over x plus 6 is less than or equal to 0. I'm going to choose to divide by negative 4 on each side. On the right, 0 divided by negative 4 is 0, and we can change the direction of our inequality. This leaves us with x plus 8 over x plus 6 is greater than or equal to 0. We now have critical values at negative 8 and negative 6, which we can now start to analyze. I will choose negative 9 on the left, negative 7 in the middle, and 0 on the right as my test values. When I substitute negative 9 in, the numerator and denominator are both negative, and when I divide negative divided by negative, I do get something that is greater than or equal to 0. So values to the left of negative 8 will work. When I substitute in negative 7, the numerator is positive, the denominator is negative, and the quotient is negative, and that will not work. The value of 0 substituted in will give us 8 over 6, which is greater than or equal to 0, and so values to the right of negative 6 will be part of our solution set. Now, because this inequality includes the equation, or equality, we would include both of our critical values. However, negative 6 is not part of the domain here because it provides or creates a 0 in the denominator. So our solution is going to be the set of values from negative infinity to negative 8, which we include, united with the open interval from negative 6 to infinity.